Right, question 8, final question of the paper, is what some students would call the K question. Um, and there's quite a lot of show that's going on here. So, first bit is actually only worth 1 mark, but we've got a curve and a line, and it says the x coordinate of any point of intersection. So we're trying to find out where this curve, which is sort of quadratic, and this line intersect. So find the intersection of two lines as simultaneous equations. In this case, they both say y equals, so the easiest thing is to make them equal to each other. So x squared plus 3k minus 4 times x plus 13 equals 2x plus k. Now, there's only 1 mark available, so if you make any mistakes, you're going to lose that mark. Right, notice that what we're trying to show is equals 0. So I'm going to expand the brackets. 3x minus 4x plus 13. And I'm also going to move everything onto one side. Now I'm going to have a look at what we want to show. So what they want us to do is factorise the coefficient of x. So x squared, let's have a look at what I've got in terms of x's. I've got 3kx minus 4x minus 2x. So straight away I can see that's going to be 3k, and I've got minus 6 times x plus 13 minus k. And then we're just going to take 3 out as a factor of that, and I've got what they asked me to show. Okay, so we've shown that. Now they've given us some information, and they said actually the curve and the line do not intersect. Now if they don't intersect, that means I'm not going to be able to solve this equation that I found in part A. And it's a quadratic equation because it's got an x squared. If you can't solve quadratics, just like question 7, it means the discriminant is less than 0. So that means that b squared minus 4ac must be less than 0. Let's have a look at our equation. B is the coefficient of x. That means in this case, b equals 3 times k minus 2. If you find it easier, you can multiply that out, so it's 3k minus 6. I also need a. Well, a is 1, because there's an imaginary 1 in front of the x squared. And I need c. Now c is all the numbers that are left that aren't in front of x squared or x. So that means in this case, c equals 13 minus k. Let's put all that together now. So b is 3k minus 6 squared minus 4 times a is 1 times c is 13 minus k, and that must be less than 0. When I multiply that out, remember that this is double brackets. Okay. And then also when we multiply out the second bit, we have to be careful because we've got minus minus. So 4 times 13 is 52, but then it's going to be plus 4k. So that's 9k squared minus 18k minus 18k plus 36 minus 52 plus 4k less than 0. Combine all your k's together. So I've got minus 36 plus 4. It's going to be negative 32k. And then combine your numbers. So I've got 36 and minus 52. That's going to give me minus 16 is less than 0. And that's what they asked us to show. Okay, even if you couldn't do those bits, we can still do part 2 because that was a show that, so they've given us the answer. So that was B part 1. B part 2, they want us to find k, so they want us to solve this quadratic inequality. So the first thing we need to do is find what's called the critical values. That's where the graph, if we drew this as a graph, would cross the x-axis. So we're going to make that equal 0. Now you could use the formula or complete the square, which is going to be quite difficult, well, tricky with these numbers. Might be easier to factorise it. Now we need have a k term and a k term. We need two numbers at the end that multiply to give minus 16. and we need two numbers in front of the k, they're going to multiply to give 9. There's various methods that we're going to think about what we could do. We could either have 3 and 3 in front, or you can have 9 and 1. And to give minus 16, you could have 1 and negative 16, or 4 and 4, one of which has to be positive and one of which has to be negative. So if we think about this and work this out, let's try 4 and 4. One of them positive, one of them negative. Now that would give me minus 16. I need negative 32 in the middle. So if these were 3 and 3, they would cancel. That wouldn't work. It's going to be negative 32, so I need quite a big number. Let's try 9 there. So negative 4 times 9 will give me negative 36. Plus 4k will give me negative 32. Okay, that's going to make us, k is negative 4 over 9, or 4. Now that's what's called the critical values. It's not the answer. That's what helps me draw the graph. So let's draw a graph. I've got negative 4 ninths, and I've got 4. These are my values of k. It's a positive x squared, k squared, sorry, rather than x squared. So the graph would go like that. It would go up. Now I want this to be less than 0. Less than 0 means below the axis. So that means this section of the graph here, and I want k to be in between those two numbers. K is going to be in between, and when we do inequalities, all the arrows point at the smallest number, the lowest. So that means my final answer is that k is greater than 4 ninths, but less than 4. It's one region on the graph, so I can write it as one inequality.